This is going to be the really hard one to follow here. Poker 4. Well, I'm not sure it's hard to follow, but I don't want to bury you guys in detail, but I just want to highlight some of the things to kind of give you a general idea of how this program will, how it kind of is organized. Okay, so let me actually run it first. This version actually can tell you who won. Poker 4. Okay, there's going to be two files actually that you create. You're going to create a package called Poker Logic. Most of your code is going to go into Poker Logic, and Poker Logic, like a good package, is going to have a testing section. In fact, I think 2/3 of the code is actually just for testing, or maybe half. Because you need, like, the issue is, like I say, you're going to have a hand. You got to be able to figure out what it is. Is it a flush? Is it a straight? Is it a one pair? Is it a two pair? Is it a three of a kind? Is it a full house? Four of a kind? And so that's what I mean. There's got a lot of detail. I don't want to bury you in all that detail. I don't want to walk through how every single one of those things is determined. But there is kind of most of them are done sort of in a similar fashion. So we'll talk about that. But then the testing itself, needs to be done in a particular way. So let's open Poker 4. I'll run it. All right. So should we go for the flush? What's that? Like if we got rid, if flush with the clubs, get rid of 2 and 5. Or what were you thinking? What were like 2? Yeah. Oh, yeah. Actually, this particular, I think this particular version treats ace as only as a low card.
Oh, gotcha.
Okay, so it's ace 2, 3, 4. If you can get a 3, right? No.
Yeah, I don't remember what's higher though. A flush or a straight.
I think a flush is higher, or less likely to get, but straight. All right, so let's go with the straight. So we're gonna get rid of the 8. We're gonna hoping for an ace 2. We're hoping for a 3. Ace 2. That we get a 3, 4, 5 would be a straight.
I guess statistically, it'd be the other way. Your option, flush. You get to pull out 2. But you get 2 chances to replace the card. You only get to fill it.
All right. So we need to get rid of 2 and 5. So I'm in fact going to type them in not in the ascending order. So 5 and 2. Do you guys follow what we're doing? We're trying for all clubs. So we're getting rid of this card. And we're getting rid of this card. And we didn't, but we got another ace. We have 1 pair. And the computer doesn't have anything. It has a high card. So notice this program now figured out that there's a 1 pair. And whereas it also figured out high card means you don't have pairs of anything. And your hand's value is based on the strong, well, actually it's going to be the king, because we don't treat the ace as a high card. Right? So this is a weaker hand. Okay, so it says you win because we had a 2 pair. So the question is, how does it do this? How does it figure out? May I ask you guys, how would you do this? It doesn't use anything that you guys don't already know in Python. How about that? So if you have a hand, okay, like, okay, say you have this hand, how would you figure out you've got a one pair? Without writing gobs of like, if this card equals that card. No, we're just doing this.
The pair is the aces.
Yeah, right. So we need to analyze this in many different ways. But we're gonna just consider the step where we say, is this a two? So, you're gonna go through and you're gonna say, is this a flush? Is this a straight? Is this a two pair? Is this a one pair? Is this a three of a kind? So until you figure out what it's only gonna be one of them, So this is just a check to see, is this hand a two pair? So how would you go? Okay, so let me give you a hint. You remember the dice program? How did you count? How did you keep track of, what came up? Right. Okay. So I think there's 13. Ace through king is 13 cards, right? Yeah. Okay. So how would you count? Yeah. How many? Good. So, how would you know you have a two? If you have this dictionary now, so yeah, it starts all of zeros. She just said all starts zeros. Then you start counting. So there's like a key that says ace. Every time you encounter an ace, you increment that. Every time you encounter the eight, when it encounters the eight, it increments the 8 by 1. Then increments the 4 by 1. Increments the 10 by 1. That finds another ace, so now increments the 1 to 2. Okay, so now you have a dictionary that has 2, mostly zeros, and a couple of ones. How do you know you got a one pair? Oh, it's simpler than that. So
could you make another dictionary of all the hands?
Simpler than that. Okay, so we. So let me ask you this: could that hand be a three of a kind? If you have two, mostly zeros and a couple of ones, that would rule out three of a kind immediately, right? Because what would you need in that collection of values? You need a 3, right? So we only have a 2, right? So how many 2s do we have? So what's the most number of? Okay, so two, and you have 5 cards. You only have right. So you can have 1 2 or 2 2s, right? So if you have 1 2 in the whole thing, everything else is 0 and 1s, then it's got to be a pair. It can't be a 2 pair, it's 1 pair. Okay? So if you grab the values and you sort them, where's that 2 going to end up? At the end, okay? Now, if you work backwards, you find a 2, then the other things you're going to find are the 1s. You go 2, immediately find the 1s. What does that tell you about that particular hand? There's 1, right? So what if you find a 2 and then another 2? That's 2 pair. So you use almost exactly the same process of tallying things up. And then you look at the values, and the values will tell you, is what the hand is. What if you have a 4, because you only have 5 cards, so 4, and there's only going to be 1 1, all the rest zeros. You do your sort, find a 4. What does that tell you? 4 of a kind. Right. So okay, so for flushes all the same suit. So like if this was all clubs, which we tried for, what would you expect? Okay, so you're gonna have a different dictionary now of just the suits. So what if it's a flush? What number would you expect to find? 5. And if you don't find a 5, it's not a flush. You know, that test is like, is this a flush? That's all we want to know, you know, true or false. Okay. The only somewhat complicated one is straight. Because a straight is a sequence of cards that don't skip any cards. So maybe that would be probably one to show you guys, because it uses kind of uses, but not kind of, it uses a second dictionary, and it also it actually kind of answers one of your questions from a couple of weeks ago. Okay, so if you just were to sort your hand by alphabetically, okay, it turns out I'm almost certain the numbers come first in the ASCII alphabet. So this would sort into 4, 8. Actually, I think the 10 would come first. Yeah, because of the 1. So it's, and then the aces would be at the end. It would sort of be nonsense. So we need to give each one of these cards its own special value. Like everything from the 2 to the 10 just keeps the 2 to the 10. The ace gets a value of 1. Jack gets 11, queen 12, king 13. So then when we sort by their associated number, like if ace is 1 and 10 is 10, we'd end up with the 2 aces first, 4, 8, and then 10. So the question is, how do we do that? And it's you might write a little code to show you guys how to do that. So yeah, actually, well, first I'll walk you through it. Okay, first of all, the main program is pretty short. This is the whole program. So most of the really you know, the most of the work is done in this package. Okay, so let me open that. Okay, so first of all, this package is full of functions. Okay, and this is where our display code is gone. Okay, so the display code is in the package. It's no longer in the main program. I think dealing the hands is still here, but that could also be put into the function as well. Generating a fresh deck is done with a function. By the way, this poker logic is abbreviated as PK, so you can just write PK down. This is very much like PyPlot being abbreviated to PLT. So here we've abbreviated to PK, but this generates a deck. Well, what does it generate? What code is in generate deck? It's the code you guys have written before. So it just generates a deck, a list, cards. By the way, cards are now dictionaries themselves. It makes the code a bit easier to read, because then you don't have to remember whether rank and suit are 1 or 0 or 1. You know, index 0 or 1. When card was a list, you have to remember that. This is a lot easier to remember when you just use these keys. Okay, so it just builds a deck. That one. Okay, but then it uses display hand to display a particular hand. This, you know, does that. Yeah, this is the code you'll write for the other program to do the replacing. Okay, so then display hand displays the updated hand. Okay, this is the one that's probably does the really complicated stuff, which is what kind is this hand? You get back a kind, which is the name of the hand, the name, like flush, straight, two pair, one pair. So then you can print out what kind of hand it is. I'm sorry? Yeah, when you have a hand, it can only be one thing. So, I mean, if you have a two pair and you call it a one pair, ignoring the other pair, then you do that to your own detriment. But this, if this is a two pair, this will say, what it'll do, it'll have that tally dictionary. It'll find the two twos and say, it's, two pair.
Full house, which is air.
It's not gonna say, oh, this is straight and a picture that's.
Well, it actually, no, let's see, it couldn't be a straight. If you have a pair, it couldn't be a straight, right? Exactly. But it could be a flush and a straight, which is a really good hand to have. It could be like it could be 2, 3, 4, 5, 6 of hearts. That and it does actually detect that situation, which is, what's it called? Is a straight flush? Okay, and then the royal flush is the very good one at the end, right? The one that has the 10 jack thinking. Yeah. So, but it detects the straight, right? That if it's straight and a flush, it also detects that. So, but so it returns one name, and then there's another function which is given. Actually, it passes in the hands. Given the the kind, it can determine who the winner is. By the way, for a full house, what would you have in your tally?
We would have 3 of a kind, a pair, and a full house.
Well, if you have 5 cards, you have 3 of a kind and 2 of a kind.
Yeah.
So in your tally numbers, if you have a 3 and a 2, that's the end of the story.
And then if you have a 3 and a 2, then you just say like.
Yeah. No. So in fact, I'll show you in. Okay, so this function, what kind is this hand? Actually, it checks to see if it's a flush, if it's a straight. So if it's a flush and a straight, it returns that. Okay. And if it's just a flush hand, it returns this. And if it's just a straight, it returns this. But then there's some other functions, like is 4 of a kind, is full house, is 3 of a kind, is 2 pair, is 1 pair. And if it's none of those, it's what's called the high card, which is that nothing matches. And then you just, the value of your hand is the highest card in your hand. Just that one card, it's the highest one. Okay, so here's is flush. Okay, here's that dictionary. Starts at all zeros, goes through and tallies things up. Okay, and says, give me the values. So, and if you get a 5, one of these, it doesn't know which one, but one of them has all the cards fall into that one category. So is a flush. Okay. And then this is the is straight, which is much more complicated. But here's 4 of a kind. Okay, the dictionary with all the different possible cards, all starting at 0. You go through, you tally them up. You grab the values. If there's a 4, it's a 4 of a kind. So using dictionaries and this little bit of logic just makes it so simple. It's amazing. And most languages don't have dictionaries. So, you'd have to kind of somehow invent your own dictionary if you're working, for example, in a language like C. Which would involve just tons more code. Here, like in 10 lines or so, you can figure out if a hand is a 4 of a kind. Here's a full house one. If there's a 3 and a 2 in the values, it's actually, I don't even sort them. There's a 3 and there's a 2. That's the only, all the rest are going to be zeros. 3 of a kind. If there's a 3, it could be a full house, but we check, actually the way this is set up is it checks full house first before it checks for three of a kind. So I kind of get away with, I should definitely like have some additional code here that says, is there only a three, 311. So on and so forth. So it kind of goes, so there's a lot of functions that are very similar. They have this dictionary, does the tally, and then does a little extra logic to figure out, what that tally means. In fact, you could probably turn that thing into a function itself so that you're not repeating this code over and over again. All right, so how does the straight work? The problem is that 2 to 10 would have these natural values, but Jack, Queen, King, and Ace. Oh, actually, it does treat Ace as a high card, not the low card. All right. So it has to give them these kind of associated values. So this is what's called the rank value. So this is the rank. So like the rank value of a 2 is a 2, but the rank value of a king is 13. So what this function does is, given the card, it looks at the rank, which gives you the key, and then returns the associated value. So for example, if you pass in a king, rank is going to be king. It's going to go into our rank value dictionary, and it's going to return 13. This is kind of a weird thing. It's a function inside a function. Have you guys seen that yet? Okay, you can do that actually. So this is a function. The only place you've seen like functions inside things, well, the TK inter, you're writing some code, and then all of a sudden for the button, you need to write a function. And the convention is to create the function right with the button code. So you're not putting it at the top. It's a different convention that you put the function that belongs to the button goes right with the button code. Same thing kind of here. It's not exactly the same thing, but this function is used by this function. So we're just going to define the function inside the function. This project, by the way, you probably might be relieved to know that there's it's not entirely complete. The solution isn't complete, but there's a lot of solution there. So, and I think a lot of the straight stuff is in there. It should.
I think we should say something about sort of would be to like make a list, say, and then put the list in whatever order. And say that the key in list, key, and then you make a new dictionary, and then you just say that key has the value for these things, and then you make that dictionary into the original dictionary.
Not sure I followed you all the way there, but you might be thinking of something. But this, in the final analysis, we need to put, if we're going to figure out if a hand is a straight, we need to put it in order. Okay. So imagine we have a 10, Jack, Queen, King, Ace. Okay. If we were to sort them alphabetically, it would just sort them string wise. And, King, it'd be Jack, Ace, I guess it'd be 10, Ace, Jack, King, King, Queen, which is not the order they should be in. But if we sort them by the associated value, then you would end up with 10, Jack, Queen, King, Ace.
You just do a list of the dictionary.
When you say a list of the dictionary, if you do list, and then that's just going to give you a list of the keys.
Or a list of the values, so that you just know that it's in order.
Which dictionary are you talking about?
For ranks. Because I think before you said that the dictionaries weren't saved in any particular order, then I think it's just whatever order you write it, that's what it's saved in.
Okay, so this is our right, this is our tallying dictionary. Okay. Um, and I don't think, actually, I don't think we even use this here. I'm not sure what this is doing here. I think we can. We're not tallying. Okay, so what we're doing is we're sorting the hand. Okay. So if we sorted it just by, you know, by the ranks, just the strings, we'd end up with kind of an alphabetical ordering.
I'm saying what if we didn't sort it? Just came out with the-
Okay, so let's actually come up with a, let's see if we have a, yeah, I'm sorry? Sure. Yeah, I think, let's see here. Let's come up with, let's say that the card you were dealt is, let's say, king, jack, 10, queen, and ace. Okay, which it turns out to be a straight, you know, but it's not in, you know, immediately recognizable as a straight. You know, what the order we want is 10, jack, queen, king, ace. Okay. So somehow we need a process that takes these strings and puts them in this order.
So you're not doing it based off of the tally, you're doing it based
No,
off-
no, okay. What part of the subway?
I don't know if we put it up, but the subway dictionary we made when we went along.
Okay.
So we,
Well, actually, you're onto something there. If you said each card has adjacent cards,
yeah,
that might be a completely different way to do it than the way that I ended up doing it here.
okay,
But that's actually a clever idea, that you somehow go through and each card needs to have one or two neighbors in that hand. Actually, I'll think about that. I'll see if I can write up a version of it.
okay.
But I'd rather kind of continue with,
Yeah,
yeah, okay, okay. So, okay, so let's say the king is given the value of, 13. The jack is 11, and the 10 is a 10. The queen is a 12, and an ace is a 14. So if we sorted these numbers and it just hauled along these strings with it, in fact, yeah, kind of a way to do this would be, for example, to create like these little dictionaries. So you have king 13, like, so rank and rank value, rank value. So that's another way to do it. Okay. But what we're going to do here is we've got this list here. And we're going to sort this list. Actually, I should put quotes around it. Except now what's going to define the order is not the alphabetical values, but instead for each one of these strings, we're going to go off and get its corresponding number. Okay, the question is, how do we do that? Okay, it has to do with this sort statement here. So we're going to sort it using this function rank value of card to determine what its kind of strength is, or rank value is. See, this is what we passed in is this function. And what is this function returning? It's returning one of these numbers. Okay, so if the card is a king, this function returns a 13. So what sort does is this sorts by these numbers rather than by the strings. And so it moves the cards around, shuffles them around, and puts them in the right order. It didn't look at all at the names. It just looked at these numbers to figure out what order they should be in. Like probably an easier way to, there's different ways to, this is kind of a pretty complicated version of using sorting by something other than alphabetically. But imagine you had something like this, a list of strings. Okay, and you wanted to put them in order of length. Okay. All you'd have to do is do, let's say, call this guy A. A dot sort key equals length. Okay, because what does this function length do when you get this, when you pass it the string? Right, the number of characters. So if you're going to sort using this function, it's going to sort them by length. So it's not going to sort them alphabetically. So end up with high, ABC, and then this other one. You can make, as long as it's a function, it's got to, as input, it's got to take an item, and output, it returns something that defines the order. So if we're going to sort by length, the length, so it's a number. It doesn't always have to be a number, but usually it's a number. The input is an item. So length takes a string as an input and returns the number of characters as the return value. In this particular case, it takes, actually, this function doesn't take the rank, but it takes the card. So it gets the rank from the card and then returns the corresponding number. So it takes a little, it's now we're kind of getting into something that's a little more might be a little hard to sort of exactly imagine, but the length thing is probably, hopefully gives you a kind of clearer sense of, both of you guys following this? That want to sort this by length, you pass in length. Here we're cooking up our own special function. Pass in. So it's going to sort the cards according to these numbers. And I think this has a solution at the end. Not the complete solution, but I think the straight thing. Yeah, I think the straight thing is in here. Okay, so the last, now that we've sorted the list, how do we figure out that we've got a straight or not a straight? We're optimistic. Well, actually, implicitly optimistic. We're going to assume that it's a straight until proven otherwise. And we look at the rank value of two adjacent cards. So we start with this. Okay, we start with n equals 1. That's what range is starting with. Goes up to, but not including 5. So n is going to be 1. Okay. So this is going to look at card number 0 and compare it to card number 1. So it's going to call that our previous card and our current card. And so it's a rank value of the current card minus the rank value of the previous card is not equal to 1, then it's not a straight. So if you have two adjacent cards, which kind of gets into your adjacent thing, okay? And if their rank values Okay, so for example, if you have a 2 and then a 4, the rank values will be 2 and 4. 4 minus 2 is not 1. It's not a straight. This is after we've sorted. So, if they've been sorted and it's really a straight, you'll find a 3. Same thing with our, for example, if you have a jack and a queen, actually a jack and a queen. So our previous card is the jack. Current card is queen. So the rank value of the queen is going to be 12. Rank value of the jack is 11. So the difference is 1. But they keep going. You keep going until you find 2 adjacent cards that don't differ by 1. And you return false. If you go through the entire hand without any problems, you return true. That's not straight. So this is the most complicated logic. And this is, you don't need this. Most of the code is this function. All right, so there's one, okay, so there's another thing that uses sort of rank values is now, okay, so you have a name for each one of your hands. So like, one's a 2 pair and one is a, by the way, this program, if you get 2 pairs, you can't tell which one's stronger. We need to write additional code. So let's say one hand is a 2 pair, another one's a flush. Okay, if you were to like say this 2 pair, the string 2 pair greater than or less than a flush, it would just compare them alphabetically. It wouldn't make sense. So once again, we give each one of the hand types an associated value. So then we get for each hand, we figure out what its type is. I call that rank, but it really should be kind of type. And then we use this dictionary to figure out whether hand 1 or hand 2 is better or if they're both the same. I think that's also the winning hand is also. The solution provides things that have pretty, let's say, moderately complicated logic. All right, so the last thing notice this goes on, this is a long program, 360 lines. It's a lot longer than stuff you guys have written. But a lot of it is testing code. So, and a lot of it is testing data. Okay, so to test your flush function, okay, you need to call it with a flush hand that you've constructed. Notice all hearts. So when you pass this hand into your flush, is it a flush function? It should say true. Then you construct something that definitely is not a flush function, not a flush hand. Pass that into yours as a flush and should return false. So you need 2 hands to test each type. Now there's whatever, there's like 8 or 9 different types. So then you can have like 16 or 18 different hands. I didn't provide them all here. And this is the testing code. The positive hand is like, for example, if you're testing for a flush, you use the hand that's actually a flush. That's the positive case. The negative case is you testing with a hand that's definitely not a flush. And then there's the string, which is the expectance called. Well, I've set this up, blah, blah, blah. Probably confusing you guys at this point. The test cases are the hand that is the thing, the hand that's not the thing, and then what you're testing for. So, and then this is a list. Test cases is a list. So you get the first test case here, and you try both. So you say what? Yeah, you do what kind is this with the positive one? and also with the negative one. So then you can check, because like imagine like, you pass in a real flush, and it says, yeah, it's a flush. Then you pass in something that's not a flush, and it still says, yeah, it's a flush. So you can just write a function that just returns true for all the hands you pass it. So you want to make sure that it works to recognize when the thing is the thing you're looking for, and it also rejects the things that are not the thing you're looking for. So hopefully making sense there. So what you'll end up doing, the bottom, long and the short of it is you'll end up creating a lot of test data. Okay. And then using this code to run through the test data. And what's actually, I'll show you sort of the really nice thing about this. Let's see here. Save that. So this is just like any package. When you run it, it runs the test data, the test code. And so here, it's testing. Well, actually, the pass means it passed the positive and passed the negative test. Now it's testing for straight, positive, and negative. So this one, it tested a thing that was actually a straight. This one tested a thing that was definitely not a straight. So, and if you, for example, if you have a bug, like deliberately make a bug, let's say 0. Okay, so like it'd be absolutely horrible. Okay. Right. So you'll see, okay, a bunch of places where it says fail. Right? For example, here, it's testing for a straight. It failed on the positive test. You passed in a straight, and it still said it's not a straight. So now you know to go look at the code testing for a straight. And then there's also you're testing for a straight flush. So you passed in something. In fact, you passed this thing here in. That should have said, yeah, that's a straight flush. But for some reason, the function didn't work properly. So the reason to write the testing code in this way is it automates this. Imagine manually testing this, like testing each one of your functions. You never actually I guarantee you wouldn't test everything you needed to test, and it'd be an insane amount of work to do even what little testing you do. But so you just look for the fails and then fix the fails and make them all passes, and let the computer do most of the work. Anyhow, okay. So this is like the really long project, let's say. Okay, so let's briefly look at this. The other set is actually really short. See here. So that's the end of this one. This kind of a lot of projects in that one.